kind of the first thing I wanted to lead off with was costs. And as all of you are fully aware, you can on this chart, and this came from Scott Zinhofsky's division at headquarters, and it goes to 2022. There was nothing more recently updated, but you can see the spike, particularly post-COVID and the supply chain problems and so forth. And I went ahead and I found this is actually from an outfit called Construction Analytics, and it's a national firm. For any of you building a house, my condolences, because the red line is residential. You can see what happened there in latter part of 2020, 21, which you're all, if you were building a house, fully aware of. The green line is actually the non-building, the infrastructure cost data. There is a little more recent data that's come out that the cost inflation has flatlined. And I think you'll find that primarily because construction is heavily energy intensive. So obviously energy costs, as they inflate construction immediately as well. So that has flattened a little bit, but the other thing I kind of want to mention with the construction cost index, though, is more and more you're seeing, in the old days when I started, the cost indexes were basically narrowed to three categories: aggregate or rock, Portland cement, rebar, well, four, I guess, and asphalt pavement or asphalt liquid. And more, those are becoming a lot smaller percentages of the project cost because you have things like stormwater control. You all know the drill of all the add-ons of construction projects, and they keep eating up a bigger chunk of that total dollar amount. And I don't know that there's anything we can do about it. It's just what society's demanding. So, but you're likely to see more of that with environmental product declarations and all of that. That's going to add another layer of bureaucracy, for lack of a better term. That's obviously that cost has got to be captured someplace. So just kind of a quick review of what I'm going to cover, and Sharon's kind of already mentioned this. Quick review of 2023, some specification updates, and these will go back a couple years since it's been 5 years since you were in renewal class. And then kind of cap it off with kind of the innovative construction technologies that are out there that most of you have probably used, that I think are a great boon to our business, particularly with the troubles getting help or getting people. You almost have to use the technology to extend your reach or you're lost. And so I think we'll talk a little bit more about that. Picture at the right was the SMA job out on I-94 at Crystal Springs Lake, west of Jamestown. The Northern Improvement job. And then hopefully Mark's online from Fargo. There was a project completed last year, an SMA job on another one on I-29 in the Fargo district. So we'll talk a little bit more about that from a construction aspect, because many of you probably haven't seen one, but I think you'll see more of them because it's a really good premium top lift or wearing course on high volume roads, high truck traffic roads. And we have a lot of mix out there in North Dakota, particularly, post the Bakken stuff, the oil boom, that at some point is going to need, support either with a wearing course or some type of additional structural add to buy out another 20 or 30 years. So we'll talk more about this. Sharon mentioned this is the online presentations that are posted out there, and they're really good presentations. And they're a prerequisite for your renewal. And so make sure if you didn't get the email that has these or can't find them on the DOT website, rather than repeating a lot of this that we have in the past or have had Tyler or John Stork or somebody come in, Scott Witzke, they have recorded sessions here, and they're all really good, and they're all relatively short. You can kind of see 15 minutes, 9 minutes, 17 and a half minutes. So, and you can hit them like I did. I think I did Tyler's first, the update at the top, and then haven't been heavily involved since I retired with the balance mix design, and that update is good. That's another Tyler. And the field sampling testing manual and the specification updates are great. The e-ticketing one as well. So anyway, before Sharon will cover later how you take your written test for renewal, for the certification renewal, but you're definitely going to want to go through these. And they are well done, easy to do. So I highly recommend that you do so, and maybe at some point even return to them. So just kind of some quick overviews, again, covering the last several years. North Dakota DOT Test Method 5, which is the sampling, hot mix asphalt sampling, was changed a couple years ago. It officially allows sampling mixture from behind the paver or from the windrow. And so that allows you the opportunity, as most of you know, with QCQA super pay projects, the length and tonnage, generally the project's done with a windrow. So, and that by far is probably the safest place and the least impactful from a destructive test location to grab your field mix samples. So that's in there. The rice test we'll talk about tomorrow, but essentially that was a relatively small change, allows the use of potable water. A couple of the other changes, if you're out in the field, and you're probably familiar with these because they've been around for a year or two now, is the contractor QC generates the random number for their QC mix sample on the road now. The engineer, in this case, the capital E, if you remember, is always the DOT or their designated representative, the agency. Still generates random numbers for the QA and the three-way split with IA, but QC is responsible for doing their own random numbers, and stress random number here underline to get their QC mix sample. The coring was a change made a couple years ago. Instead of taking the two side-by-side cores per 2,000 foot paver, one paver width wide, excluding shoulders, now it's still the two per 2,000 feet, but it's broken down or subsetted additionally by one core per 1,000 feet. And so you obviously, most of you have probably been on asphalt jobs, so you got to pull two random numbers, actually four per sublot, one for the length and one for the offset. I don't know what the status on this, but I know this came from Tyler probably a couple years ago, is the lot size, and again, that's the acceptance quantity based on sampling and testing, is transitioning to 2,700 tons. And that's to kind of get the statistics in place and to handle those end of day, early day. When you look at most of our projects with a portable hot plant, parallel flow drum plant, if you're running 600 tons an hour, 500 tons an hour, that's 4 or 5 hours basically. That'll go out on the road when the weather's right and we're making hay. So talk a little bit in this class, not much, only how it impacts your paving process, but the transition North Dakota made for asphalt binder to AASHTO M332 from M320, which is the massacre multiple stress creep recovery requirements, which Minnesota has. South Dakota hasn't yet, but they're going to, I think, in the next couple of years. So it puts everybody on the same footing from asphalt specification standpoint, binder specification. Longitudinal joint density acceptance has gone through a couple iterations. I think it's settled in probably where it's going to stay now. It's been very effective, and it's a standalone standard special provision generally when it's on the project, an SSP. And standalone meaning that you don't have to translate it to the tonnage place that day. It's based on linear feet of longitudinal cold joint in the travelway. And so it's a lot easier to track. It's a lot less paperwork on the field level trying to say, okay, what's pay tonnage, what's non-pay tonnage, what's shoulder, what's field approaches and stuff. It's a lot easier to apply. And to me, it gives you a lot better, for the DOT, a lot better ideas. Are we getting the intended effect, better density at the longitudinal joints? So Some of these, and again, there's a good video that's posted that you should look at on balanced mix design. There's been one job I think that's been let that's a balanced mix design type project. Primarily affects the mix design, obviously, but obviously from that the aggregate selection and so forth. And a lot of this, and we'll get into a little more detail, is based on performance testing the mixes. And the DOT has pulled the retained samples from a number of jobs 2 years ago, basically from every job, and last year from specific jobs in each district, but splitting that into 3 samples per project, one in the first third of production, one in the middle third, one in the last third, so that you get an idea of what's happening to the mix and the performance of that mix from a testing standpoint during the course of production of a larger ton project. So the regressed air void has been in place in most cases. You've probably seen that already. One thing that does from a construction standpoint is it puts a little more asphalt binder into the mix, particularly when you're working with a wrap mix. And so that tends to take a little bit of that harshness that a lot of time a wrap mix introduces into the process, because obviously wrap's a processed aggregate already and has aged asphalt and so forth in it. And so that particular item there, the regressed air void, by putting a little extra asphalt into the mix during production, actually should help you with density. Because if you came through pavement inspection class when I was teaching it, we talked about asphalt binder as an important factor in density, because when it's hot, asphalt binder works as a lubricant, which means that it'll help reorient that mix under the screed, under your rollers, compared to a lower asphalt content mix that doesn't have as much lubricant in it. And then, of course, as that asphalt cools, though, it becomes the glue or the cement for the mix. So you have roller passes and you have effective roller passes, and effective roller passes only happen when that mix is hot enough that that binder is working as a lubricant, not as a glue. So we'll talk about that a little bit. The density profiling system is one advance that I think is going to greatly impact and has greatly impacted the paving process and also the acceptance process. And ultimately, I think will be the acceptance tool as opposed to going out and running a core every 1,000 feet. So keep you off the road at 5:30 in the morning in the middle of live traffic trying to take cores and then patch those core holes. So we'll talk about that and then wrap as well. So starting off, just that I mentioned the transition to AASHTO M332, the massacre graded system. This is a chart I think Jeff Herman put together and Joe Davis several years ago, just to kind of give you a transition. In the old days, in the 320 era, you just had the 2 numbers, right? The first number is the expected high 7-day pavement temperature and the location you're paving, and that's how that PG binder was selected. The second one's the single low temperature during the life of that pavement, and these are both degrees Celsius. So what Massacre, the 332, did was combine it so that you're testing that binder at what the pavement and the location's telling you should. So you see all 58s in the left column, and all that dictates is that all the tests we're doing on that binder are done at 58 degrees C. Because before, on the right column, you'll see some 64, some 70s. I think in Dickinson, they even did a PG 76 several years ago on the 22 bypass. And those were called grade bumps, and they were done to increase the strength of the binder. And that normally came about by adding more polymer modification to the binder to account for higher truck traffic or slow moving truck traffic or starting and stopping truck traffic. Well, now we still test at 58 degrees, as you see in the left column, but you see the letters, the suffix behind the high temperature number. And basically you can think of that as 58 standard for the S, 58 high for the H, 58V for the very, and 58E for extreme. And those base suffixes basically address the expected truck traffic and the type of loading that pavement's going to get. So as you go up the line, the minus number should, you'll see that in a second, should stay mostly in North Dakota at the minus 34, because that's the single low temperature pavement temperature and air temperature at the surface of that pavement that's going to dictate the susceptibility to thermal cracking in our environment. So that part stays the same, but as you go up from S to an E, basically you're bumping the polymer strength by increasing the amount of modification, which is typically a polymer or latex to help with that stress strain relationship in the binder and therefore in the mix. So wrap, there's a lot of work going on. This is the standard verbiage in 430 section, the standard spec. Rather than mentioning anything now, probably the bottom line there is, and this has been in for a long time, recycled material shall have a maximum particle size of 1.5 inches. So obviously that's coming off your milling stream. That's an important element both for mixing the or running it through the drum, but also for heat transfer. The wrap is what I like to call a black aggregate. It's not just aggregate, it's also residual asphalt. So heating any mix is important. Heating a wrap mix and getting uniform temperature is the only way you're going to get uniform temperature out at the road. And the larger the particle size, the longer it takes to heat it, just like when you put something in your microwave at home. So I thought I'd hit one thing. This is coming from the Federal Highway Administration Stewardship Review a couple years ago. I know before Gary Goff retired here this last January, he had done a bunch more process reviews in the field, I think primarily in the eastern part of the state, but talking to Joe, I think they hit about every district. These were some of the things that they were kind of highlighting. And so you can read those. I mean, there's nothing earth shattering there. There were some suggestions or recommendations that they were making. The middle one there, as we get into wrap and being able to get into balanced mix designs, you're still going to look at a mix design. It's still the same 3 A's, right? Aggregate, asphalt binder, and air. And the air part may change and the asphalt part may change with binder types, and the A part, aggregate, might be a combination of virgin aggregate and wrap aggregate, but it's still the same basic process, and the same basic process regardless of where the targets settle in. It's very important in the field and at the paver to know that your asphalt content is staying consistent. And how do you get that? Well, we do takeoffs, right? Every night we do a check on the totalizer every time we pull a aggregate sample for QC or QCQA. But in the process, I mean, the accurate way of getting it is, particularly when you have wrap in there, you're only measuring virgin asphalt. And what you have for asphalt content or effective asphalt content in the wrap is an important part of the process, because the mix only sees total asphalt content. So I know the feds had talked about using ignition oven. I think every district now, district materials lab has an ignition oven. You're seeing that come more and more into play. And just a note there at the bottom sentence there in that middle highlight is the materials and research purchased and has installed an automated binder extraction apparatus. I call them auto extractors for lack of a better term, which allows you to put mix samples in and do fairly quick and non-labor intensive asphalt extractions to get not only total asphalt content, but because it's a closed system, it also extracts the binder itself instead of by filtering out the solvent. So you could actually grade the extracted binder. And if that's a combination of wrap binder and virgin binder, that could tell some pretty good information over time as that proceeds with that auto extractor. So anyway, projects, quite a few projects started in 2020, continued through last year, that are kind of following up on that stewardship review. So this is in Tyler's presentation, but I broke it out a little bit different. You can see that there was roughly 1.4 million tons of asphalt mixture placed last year, bid last year. I don't know how much carryover there was in through the winter here, but the number in parentheses is 2022's number. So you can see that dropped from almost 1.9 million tons. Part of that is 2022 was a heavy year for asphalt, as most of you know. Part of it's cost, part of it's flow of money and projects. I know, like in South Dakota here, their overall surface work has dropped drastically because they're finishing up a new Missouri River Bridge here between Pierre and Fort Pierre. It seems like it's been going on for about 10 years, but they're also trying to bid a new Missouri River crossing down at west of Platte, South Dakota, which is south of the interstate, south of I-90. And that's a really long bridge, and it's something like a $400 million job. So from a programming standpoint, you see these change and flux a little bit. The binder used, I thought, was really interesting, and that's why I included Tyler's slide here. Was you can see the binder types there. We just covered that with the Massacre spec or 332 spec. You can see the roughly 60% or more when you look at the total. It was over 2/3 of it now was in that H grade. So when you get it to a 58H, as I mentioned, you're probably more likely to see a modified or slightly modified asphalt on your projects. And why is that important from an inspection standpoint? Well, those mixes tend to be stickier. That's what the polymer does. That's why it's in the mix. So from a compaction standpoint, that's one thing you kind of keep an eye on, and how you set up your roller patterns and what rollers you use, because it's a little bit different trying to squeeze air out of the mix when you got something that's really sticky. So, a quick, I guess, baseline correlation would be if you're using a steel wheel vibe as your breakdown roller, knockdown roller, and you're running a 58S versus a 58H, you might having to be bumped the amplitude, assuming your lift thickness and the subgrade or substrate support it, in going from a 58S to a 58H. So that's one thing to keep an eye on when you get your project plans and notes and you look at them, is pick off that PG grade. And as you can see, a lot of it now, 2/3 of it, is getting into the 58H or higher grade. The numbers in parentheses are last year's numbers. So you can see, almost 1/3 of it in 2022 is 58S minus 28. That's the typical base grade asphalt. No, normally, almost always, I think in North Dakota, non-modified, neat asphalt in terms of the trade. And now you're getting a lot more. The other transition has been to the minus 34, which I think is a good move by North Dakota. Again, because thermal cracking is one of the preeminent distress things that we see in our pavements, and thermal cracking leads to a lot of issues down the line from a maintenance, crack sealing standpoint, and a ride quality issue. So, and you can see that last catch-all, there was some 58V last year, which there was none in 2022, a 58V minus 34, which there was none in 2022. And you're likely to see more and more of those, particularly on the NHS routes, the high truck traffic routes. I know Kurt's Dunn from Grand Forks is on here. I think one of the jobs, University Boulevard, did a thin lift overlay over concrete, and they used the 58V minus 34, and it's performing fairly well for, as far as retarding reflective cracking or the severity of the reflective cracking on there. So you're probably going to see more of that. This is, again, Tyler. It's in Tyler's presentation as well. The kind of your catch here is on the right side. Here is the breakdown now. There's just the 3 FAA Super Pave grades instead of the 6 we had before, which is good from a contracting standpoint. And basically, it's eliminated kind of those unique hybrid jobs where you might see an FA 40 or 44s. And when you're crushing material for a 44, you basically are meeting a 45 requirement based on the specifications. So it narrowed that down, and that's a good thing. but these are the traffic values, and these are, yeah, ESL is an equivalent standard axle load. So basically it's based a lot on the truck traffic on that particular route during the design period. And then you'll see the down below here with massacre spec when you have wrap. And generally what that's accommodating is I need a much softer wrap, or softer binder, the greater the increase in wrap. So one thing I neglected to mention on the previous one though here too is wrap. So roughly about 40% of the tonnage last year included some wrap in the mix. And generally in North Dakota, that's 18 to 25% wrap in the mix. You can see that's a pretty significant drop in the parentheses here from 2022. That can be kind of a factor of the type of jobs, whether there was milling and so forth. But I think people are walking a lot more gingerly, you can step over dollar bills to pick up pennies sometimes too, if the performance of your wrap mix doesn't equal the performance of your virgin mix. And that can be done, and has been, in NCAT and others have showed that, but you really have to engineer the mix much more closely, and under our old way of doing it, 4% air voids, for example, and so forth, it was a lot harder to do that. And so I think that's a temporary downturn myself, probably a combination of those items I mentioned. But as you look to the future in the new federal transportation bill, you're going to see us up into that 60% or more category. How we get there is another thing, whether it's through full depth reclamation and other ways. But so anyway, that's the quick coverage there without getting into too many details. Again, this is Tyler's data. I just wanted to show it again, go through his videos. Well done. A lot of good information in there. This is the average mainline density number in 2023. It was 93.4. So that's basically the project averages, which are based on a summation of the lot averages of which are based on the sublot averages. So you have a really wide data set. One of the issues is it's coarse, and you can see all those cores to the left of this photo. That's big job. You basically have a wall of cores. But look past through the other numbers. I think I put those in. 2022, great year, 93.8, down to 2018, which was kind of the precursor to a lot of changes in the density specification and the density way we measure density as well. So you can see generally there's been a rise, which is a great thing, which we'll talk about a little bit later here. And then you'll see the two numbers on the average joint density, longitudinal joint density. And again, a little downturn there from 2022 to 2023, but those numbers are really good. And Kurt, I know, is on here, but he can attest to that because the Grand Forks District did a lot of work from 2016 to 2020, just running cores, reference cores, and doing core densities and bulks on what kind of densities, and finding 87s and 88s wasn't too hard to find. And that was using the Maryland joint, longitudinal, but basically butt joints for longitudinal joints. So that's a really good success story. I mean, when the specs first started coming out, I was a little bit skeptical, because obviously when you're working on longitudinal cold joint, it's two passes, right? And the first pass is unrestrained or unconstrained. And so just the physics tells you that you're not going to get as good a density on the inside edge of that first pass. And then of course, when you come by with the matching pass, you're working with a lot of things like material flow. Am I getting enough material into that joint? Am I getting enough compaction into that? And, even before all this longitudinal joint density spec came about, the North Dakota had changed the standard specifications that you have to double tack the vertical face. And that was one of the reasons why, is if I can close those voids up by double tacking them, The vertical face is I'm going to get better bond and therefore better density or less air voids in that. So, but I put this kind of together and based on that previous data you showed. And if you look at this chart, far left here, this is density, obviously, here in the vertical column. This first horizontal is historical, and Amy Bicey did this when they did the first PWL jobs, and we'll look at that pretty quickly. But the historical average, and this is thousands of projects, obviously, of FA 43, was 92.7%. That was the average. If you ran a percent within limits, you know, how much of that was actually within the spec limits, in this case, basically greater than 92.0. And those numbers showed roughly 66%, only 2/3 of them. So 1/3 of the roadway was less than 92% density, which means more air voids, which means more moisture penetration, which means more potholes and so on and so forth. So after that start in 2018, you kind of see where it started rising here with the pilot projects. The first pilot projects with PWL were in 2000, so you can see that spiked it up to here. And then what I think is interesting is the bonus or the pay table in section 430. You know, as the standard specifications changed, it introduced the concept of before or prior to that time, it was all a zero-sum game on density. The best you could get was 1.00. And that number was entered into that uniformity constant when you looked at, you know, allocating the price deductions, almost all deductions in that case, for the mix. Well, that introduced, you know, a plus side or a bonus side of that table. And depending on where your project or lot average was, if it was above the target, is you could get 1.01 or 1% up to a 5% bonus, 1.05. And you saw a pretty significant increase in the average project density up to 93.8. So that's kind of represented by these two green arrows. Well, you can see this drop in the last year. Now look at the scale here. So it's not like it's a 10% drop, but you see the drop from the 93.8 to the 93.4 in 2023, in my opinion, is one thing. Obviously, projects can impact that, the type of projects you're doing any particular year, and the pressure on the industry in when you're having trouble finding truck drivers and operators, obviously. But I think one thing that affected that table was reduced to 1.04, the maximum. And so, you know, that's kind of the thing with bonuses. And I've always preached this: in a low bid system, yeah, you have to make quality a competitive advantage. And you can say, well, I'll just put my spec where it should be. Yeah, but in a low bid system, the race is always to the bottom, because I need to get that job. And so if I can just barely meet that, guess what? I'm going to get that particular project. Well, when you make the quality a competitive advantage by the ability to achieve bonuses, and you saw that in Tyler's slide, is you really push that quality. And in the case of density, that's extremely important. You know, if it's about something that doesn't matter, who cares? But density matters. For pavement performance, it matters to the taxpayer, it matters to RIDE. And so that's something in the future to keep your eye on. You know, my father-in-law used to be a farm implement salesman, and the one I always remember, this plaque he had on the wall in his office. It says, "Poor quality remains long after the price has been forgotten." And in some cases, that's a very true statement. So, you know, our goal in the industry and with all of you is, yeah, I want something. I don't want to have to go back on that job in 8 years. And with the more expensive projects are becoming, you know, you may not get back on that project and shouldn't for 20 or 25 years, other than some pavement preservation. So something to think about. These were the total incentives. So I guess I hadn't shown that yet, but this is Tyler's slide again. Make sure you watch his YouTube video. But ride incentives total were over $500,000, almost $600,000. The parentheses is what they were in 2022. The mainline density, you can see, and part of that's the drop. You saw the average pay factor was 101.3, so basically a 1.3% bonus compared to the previous year, which was 2.5%. So you could say, if I'm king for the day, I look at it and say, well, on average is a 0.5% loss in density on all the jobs I did that year worth that 1.2% bonus that I paid. And you can see the joint density, and that's a percentage. I only had 2022 because that went to a standalone spec. So it's not a percentage based on tonnage. It's a total, I think it's 40 cents up to 70 cents per linear foot, depending on the numbers and so forth, which we'll look at here a little bit later. But the importance here is driving that, because you can have a perfectly good pavement, and if you don't get good density at the longitudinal joint, you're just setting up linear potholes right in the center of the road, by the way, or under your rumble strips as well. So on a 2-lane road. So again, just to recap, I don't know if I think Tyler covered some of this as well, but I went in and touched it up a little bit last year, and some of you hopefully probably worked on some of these, maybe have some questions or input. But the second Super Pave 5 job was done in the Fargo district last year. There was a higher wrap project done in the Valley City district last year. I don't have a lot of data on that. I'm just mentioning that. Hopefully maybe somebody online here has something to add there. You can see the drastic increase. There were 10 projects with intelligent compaction and PMTP as paver mounted thermal profile. There's more and more of those are coming hand in hand together, and for good reason, as you'll see here in a second. The parentheses was there were 5 done in 2022, and then increased to 5 projects that used the PWL, or percent within limits method, for density acceptance, and we'll get into that a little bit more here. Super Pay 5, again, this is a construction inspection, pavement inspection class. So we'll probably go into a little more detail on this tomorrow for that renewal with ag testing, mix controller. But basically, Super Pay 5 was a evolution of the Super Pay process, where you target 5% air voids instead of 4 at mix design, and you compact it to 95%. And therefore, that's what you're aiming at in the field then too. So if any of you came through mix testing class with me, we discussed this, why do we go 92 to 96% density in the mat when we're designing our mix at 4% air voids? And I try and explain that in the class, but this kind of eliminates that discussion because you're essentially trying to build it. It also includes a performance test on the mix and generally requires a lot more asphalt, but also a lot more processed aggregate. And so I'm not sure it's the answer, but I'm not sure I have enough data or smarts to tell you that. But I'm just showing you the numbers here. When you looked at the average mainline density, the blue line here, this is off the Minot job in the year before, compared to the average. This is the mainline density, and this is the longitudinal joint density here. So on that particular Minot job, the mainline average was 95.5. So I just throw that out there. Interesting job, again, more FYI, was the test section jobs on 1804 south of Bismarck. Basically, this corner here is by Mary University. So it's that 1804 that comes over here to the, ultimately, used to, sometimes still do, I guess. If I get up there, I'd always, if I was at the lab, I'd cut down 1804 and cut across to the Moffett corner on US 83. But so it's that section. A lot of interesting things done on that job, and they were fairly long test sections. Tyler goes into a little more detail on that, but again, these are pavement preservation type techniques and really good test sections. paver laid seals. The bottom two I wanted to mention, we'll talk about a little bit later here, were some thin lay mixes, actually using super pave, but 1/4 inch and 3/8 inch super pave as opposed to the 1/2 inch super pave mix we typically use in North Dakota. So the performance of those could be telling and help with future decisions on how to approach different projects in different areas with different distress levels. 2024 is another Super Pave 5 project, another high wrap project, which I'm not sure where that's at, but now you see the increase to 13 projects with intelligent compaction, paver mounted thermal profiling, 4 projects with PWL. The last one I'm kind of interested in, more because I'm a paving nerd, even though I'm retired, is it's called, or Tyler's title was machine guidance milling. And so they're going to do one project. And I think this is interesting because basically milling machines have machine guidance, right? Crown and slope control, just like a paver, just working in the opposite direction. But in this case, the point of reference you're going to use in this particular project is the LiDAR map of the existing road. So it's actually setting continuous crown and slope changes based on what finished slope you're trying to get and what thickness you're trying to take off the road, or nominal thickness you're trying to take off the road. So yeah, that to me, I don't know who has this project, what district, but hopefully you watch it closely, and you might be on the bleeding edge of the technology here, but in the future it could be really, really helpful, because you can only pave as good as what you're paving on. And when you're looking at the paving process, basically the roughness that's on that existing substrate you're paving on, best case scenario, you can improve that or decrease that roughness by 50%, improve the ride quality by 50%. If you have a really rough road, 50%, 200 inches per mile to 100 inches per mile is probably the best you're going to do. Well, if you're milling, which more and more we are doing, and micro milling, if you have something that approaches grade and slope control very accurately, your lift thicknesses are going to stay consistently, your yields are going to stay consistent, and your ride and density are going to be much better because you're consistent thickness of mat and consistent slope. So and you're not jumping yield back and forth or spread rate back and forth to account for the roadway underneath that you're trying to pave. Pavers filling the low spots and skimming the high spots. So very interesting job. Whoever gets that, or if you're familiar with that, I would say that might be the lead. And LiDARs is just a radar basis, and I think you'll probably see that in a lot of airports do that now, use LiDAR, LIDAR pavers. And again, I think a lot of the high-speed racetracks, when you pave them, they're using LiDAR guidance to do crown and slope control, not an extended reference on the paver itself. So the two match hand in hand, and so this is a great start. And milling has always been kind of the bugaboo in the industry in our part of the world, because you only have so long to do projects. There's only so many milling machines that are in our part of the world. And if you have a mill and overlay, which a lot of projects are now, you're kind of held hostage to the milling operation. It's creating part of your material for your mix, but it's getting the road ready for your paver. And depending on the road and the age and the type of aggregate that's in that pavement, in the South Dakota area, anytime you get into original pavement mixes that had quartzite in them, milling became a slow operation because those diamond bits on that milling head wore out quickly, when they're grinding against a lot of quartzite aggregates. So it was always a fight. Well, I need to slow the milling operation down to get the intended crown and slope control, but at the same time, I have to keep that 1.5 inch max wrap material under control. And the faster I go, well, if the milling company is a subcontractor, they want to get off that job and go to their next one, and they got 5 more to go after that. So there was always this constant tug of war going, and still is, on projects. And if you're using something like LiDAR-based machine guidance milling, you're not milling any more than you have to, and that should help as well. And if you're milling to a grade and slope control, speed is the only thing that's going to get you, controlling that speed and the head and so forth is the only thing that's going to get you there. So talking about DPS, mentioned that earlier. And again, John's got a YouTube presentation, really interesting to take a look at. In 2022, Highway 6, this is down south and southwest of Mandan, was this Highway 6 job. It was an FDR job. I think it was like 26 miles long, something like that, maybe longer, 28. And John ran the DPS on that full project, and it was some great data. 3 passes in each lane. You can see the DPS unit there. Roughly, you have about a 4.5, 5 foot influence. Those are ground penetrating radar heads that are on that bar. And so if you want to get the full lane, obviously you do multiple passes. So John did about 120 miles just on that project. In 2023, I think John was out there, did a lot of projects in the Grand Forks District, Fargo District. He presented it at the Capri Symposium. Capri is the Consortium of Asphalt Pavement Research Institutes, but basically it's Minroads, NCAT, and the pooled fund DOT, which North Dakota is the main one in that, looking at these different issues from DPS to balanced mix design. E-ticketing, again, less people available on a project. That started in 2021 with some pilot projects, and 2022 continued, and then there were 15 projects on e-ticketing in 2023. So there's a special provision now that allows e-ticketing on all projects. So once the system's set up, you don't have to get special approval to use e-ticketing. And DOT actually acquired this portal from Haul Hub, which is a commercial kind of fleet management software. And remember, the end goal here is to fully implement e-ticketing by 2026, which long run, obviously that eliminates a person out on the project, which is normally a person that you don't have because you can't hire them. But it eliminates kind of a small but important step in the load-out process. But probably more importantly, the software and the ability to track loads, where they're at, how much is on the road, how long is it going to take to get here, calculate yield, calculate spread rates. There's a lot of things once this is kind of put into a 0-1 format, electronic format, that are going to be available. So it's not just about labor saving or safety. I think it's much more functional than that. And probably most of you have used this by now, but just remember the goal is 2026. Some of the spec changes, and again, some of these started earlier. I mentioned the 3 FAA grades, narrowed down now to the 42, 43, and 45. There was a 1% increase in density requirement for the 100%, the 1.0 pay band for FAA 42 and 43. Remember, I think in the old days it was 91.0 as the lower limit. And there's a mixed design process. We won't get into that much in this class. The density tables in 430, I mentioned that particularly with the 1.04 and 1.05. Those are all in one table now. There used to be separate tables for FA 40 through 43, and then a separate table for 44 and 45. There are some changes coming that Sharon's working on as well, as far as the certification process in QC, QA with regard to mix controller and mix designer. And I think the only other change was a clarification of mix temps, delivery temps for patching on the project.